Hi, I'm Pastor Doug, and we're delighted to have you join us in this worship ministry here at Restoration Church. I'm here to provide you with some fundamental training in audio mixing. So I encourage you to grab a pen and some paper to take notes, as there will be some terminology that I use that is going to be important for you to understand in order for us to communicate effectively and for you to understand the operations that come with running the soundboard. So, without further ado, let's get started. Thinking back to grade school science, we remember that molecules, they're all around us. So sound is quite simply the movement of molecules going into each other and being pulled away. The force that pushes and pulls these molecules around is called a decibel. We might commonly know that as volume, which is acceptable because we now understand the terminology decibel. The other part of sound is frequency. Now, you may have heard that word before, but as it stands regarding sound, as decibel level is the amount of force moving molecules towards each other and away from each other, frequency is how often that movement happens in a specific given amount of time. So, for instance, a high-pitched sound is going to move and come together at a faster rate within 1 second, whereas a low, bassy sound is going to move towards and away from each other at a slower rate within 1 second. That being said, two completely different frequencies can have the exact same decibel level. There are many ways of capturing a sound signal or an input source, but it's either as an analog signal or a digital signal. Mics capture sound as an analog signal. This is a common dynamic microphone, the Shure SM58, and it captures sound at a very low decibel regardless of how loud the input source is. This is a condenser mic, the MXL V63M. It too captures at low decibels, but higher than a dynamic mic. It also requires 48 volts of power, known as phantom power, in order to operate. Note, never apply phantom power if it is not warranted. This is a direct injection box, or a DI box as we call it. It sends line level decibels, meaning that whatever the decibel of the originating sound, that decibel is what you will receive on the soundboard. This is an XLR cable, or mic cable as we call it. We have a male and a female end. Then we have 1/4 inch cables, or instrument cables. Here you have a TS cable, that is tip, sleeve. Then here you have a TRS cable, that is tip, ring, sleeve. The important thing to note here is that the TRS cable is required when you are connecting to something that operates in stereo. Wait, what is mono and stereo? Mono is sound being sent or received on one path. Stereo is sound being sent or received on multiple paths. We naturally hear in stereo. Even when mono is being played on multiple speakers, it's still considered mono. This is our PreSonus Studio Live 32.4.2 active integration sound console, and this is what you will primarily operate when you serve. We also have a Mac Mini here that the board is connected to that runs a few programs that we use to mix and treat input sources, but we'll talk about those programs in a bit. As a soundboard operator, your job is to control the sound being produced. Understanding a flow chart can be very advantageous, and it too can seem really confusing, but relax, it will all make much more sense later on. Overall, the sound travels from the stage, where it's produced, to the soundboard, where it is treated or mixed, and then finally to its various final destinations. Once all the signals being sent by the stage box are received by this soundboard, all the nuances of mixing then begin, before being sent back out to their final destinations. But before we get into those nuances, let's take a look at where these signals are sent. All of our input sources or sound sources come from different locations, but majority of our input sources come from the stage. In order to get to the soundboard, they're processed through our digital stage box backstage. Let's go take a look at that. This is our PreSonus Studio Live 32 channel digital stage box. This box takes all of our analog signals and converts them to a digital signal. In addition to our directly injected digital signals, places them on a local network and sends and receives all from the soundboard through one simple Cat6 Ethernet cable. Here we have 4 amplifiers, or amps, that receive the signal sent by the soundboard. They all essentially do the exact same thing, but are rated at different capabilities and send to different locations. The sound signal must pass through this amp before reaching the output source, because input sources vary in decibel levels. Therefore, those levels must be amplified. This Yamaha PX10 power amplifier receives signal from the soundboard and sends it to our front of house main speakers. This QSC GX5 power amplifier receives signal from the soundboard and sends it to our left and right mid-fill speakers. This PV IPR 1600 power amplifier receives signal from the soundboard and sends it to our subwoofers, or subs. And finally, this Behringer PowerPlay headphone amp receives signal from the soundboard and sends it to our worship team's in-ear monitors. Mixing involves 5 primary functions: level setting, equalizing or EQing, compression, gain structure, gate setting, and effects. All of the mixing operations and metering are done primarily here on the FAT channel. It can also be done on the computer here. Let's start with setting levels. First, we need to select a channel that we want to work on. Notice that I have the fader all the way down. As the input source is received, we see here on this meter that the level is being received. We are seeing the sound in signal data form versus hearing it, and this is known as metering, visualizing and monitoring the decibels of the input source. Our board has a built-in preamp, as does our digital stage box, for the purpose of setting an appropriate decibel level. If the input source is too loud, we trim. If it's too quiet, we gain. For this channel, we will use this encoder pot to trim or gain the decibel strength of the input source, since it is directly connected to the soundboard. However, most of our channels are connected through the digital stage box, so we will remotely adjust the preamp in the stage box. Let's select a channel on the network. Selecting this channel, we will use this encoder pot to trim or gain the decibel strength of the input source. The same goes for all networked channels. The target level for every channel is -10 dB, decibels. You can see that as the decibels vary from my voice, the meter level rolls over or maybe under 10 decibels. We want to set a level that is peaking at minus 10 decibels, or maybe even rolling over a little bit, but never to exceed minus 6. By doing this, we're creating what's called headroom. Headroom gives us the room to work towards improving a specific input source's sound quality. If it's too loud, it will sound distorted, and you cannot make improvements to distorted sound. Check, 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 check. With our input source decibel level set, it's time to begin EQing. When we start to EQ, we want our compressor, gate, and effects all to be off. We also want to start with a balanced EQ. The only exception here would be a high-pass filter. The high-pass filter filters out lower frequencies while allowing higher frequencies to pass through the board depending on what it is set to. We can also go ahead and bring up our fader to unity. Unity is a level in which that specific component is neither gaining nor trimming the signal. We can also go ahead and unmute the channel. I want to introduce to you now the PreSonus Universal Control program, run on our Mac. That is a proprietary program that actively shows what is being done on the soundboard. Now we begin EQing by cutting frequencies to get an overall good quality sound. Doing this from the soundboard, we can use the frequency pot, the Q pot, and the gain pot. From Universal Control, we can use the mouse cursor. You can see here that the frequency pot controls where in that specific frequency range we'll be adjusting. The gain pot controls the increase or decrease of decibels of that specific frequency. And the Q pot controls the width of the frequency band. There are two ways we like to EQ. The first is called frequency sweeping, in which we find a bad frequency, like this, and then cut it out altogether. While this is a quick and easy method, it's not the preferred method. Rather, we should aim only to cut frequencies slowly, aiming to create the best possible sound, as if this is going to be the end product. Compression is an extremely valuable tool. It's often misunderstood and thus misused, but it's essentially an automatic volume controller. When compression is activated, it reduces the decibels of the level set on the soundboard by you. So let's have a look. With the channel already selected, we'll turn to the compressor, and using the threshold pot, we'll set a decibel level for the compressor to engage if the input source exceeds that level. Now moving over to the ratio pot, we'll set a ratio level to dictate the rate at which the compressor reduces the input source. We'll go with 2:1, meaning that for every 2 decibels, the compressor will reduce the decibel by 1 decibel. So if it goes 4 over, it's reduced 2 decibels. If it goes to 6, reduced 3, so on and so forth. So with the attack, we're setting how fast in milliseconds the compressor will reduce the input source. So you can set it to gradually reduce or instantly reduce. Then the release, you guessed it, is how fast or slow the compressor will release the reduced decibel for it to rise back to its original incoming decibel level. So if our goal is -10 decibels and the sound is coming in at -8 decibels, and we set our compressor to reduce at -8 decibels, depending on how fast or slow the attack and release are set to will dictate how quickly or slowly the decibel level will go back to -10 decibels and eventually the original -8. Gain structuring may be the easiest part of mixing, as it is simply replacing what is lost. If you notice here, there's a meter labeled GR, which stands for gain reduction. So as you're running a sound check, you'll begin to see the gain reduction meter lighting up like this. Check, check, check. Whatever decibel the gain is being reduced to, you will go back to your compressor and add what's called make up gain. Check, 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 check. At this point, with your EQ cuts made, your compressor set with makeup gain, you can now return to your EQ and make any necessary frequency gains. Frequency gains are often unnecessary, but sometimes you might want to, for instance, on a bass drum, come over to the 300 or 400 hertz range to emphasize a thud or a boom. Or on a vocal mic, you might want to come to the 10,000, 20,000 kilohertz range to really emphasize the airiness of a vocalist. The ultimate goal at this point is to polish the sound before applying a gate or any effects. Setting a gate is one of the final steps to audio mixing. It includes multiple functions very similar to a compressor or an EQ. We could think of it as stage noise eliminator. But what it's actually doing is taking unwanted noise that's bleeding into mics, and it reduces the decibel level or eliminates it altogether. First, we'll start by setting the gate on and setting the threshold. With this, we are setting a level at which the gate will open for sound above the set decibel level, and to close to sound below the set decibel level. Then we'll move over to our range. This will set how much the decibel level is reduced, or we can eliminate it altogether. A nice feature on the PreSonus Studio Live AI soundboard is the key filter. With this, we can direct our gate to focus in on one specific frequency range. This is especially helpful when there is feedback. We have a hard time mixing out a bad sounding frequency. Just like the compressor, we have an attack and a release setting that works nearly the same. The attack sets the speed that the gate opens. The release sets the speed at which the gate will close. A fast gate release can be very noticeable. Take for instance a crash cymbal. When you hit a crash cymbal, there's a ring out or a washout type of overtone. Well, with a fast gate release, the sound abruptly cuts out, and it's not a very pleasant sound. So we typically keep a slower release on the gate. We finally reach the last step in mixing when we're ready to apply effects to our channels. This soundboard has effects like reverb and delay that can be applied directly to a channel. We also utilize something called a DAW, or a digital audio workstation. This is just a digital version of what we have here on this soundboard, but with more features and capabilities. I will now introduce to you the digital audio workstation we use on our Mac, MainStage 3. In this digital audio workstation, we currently process vocals by correcting the pitch and adding some reverb, de-esser, and compression again before sending it to the house mains or to our live streaming feed. Let's start with a more simple effects application. When we select Mix under either FX A, B, C, or D, our fat channel meters transform to become meters to display the level of effects applied to each channel. Each meter is linear to each channel. So with Mix selected for FXA, which is a reverb effect for vocals, we can use this pot to add or subtract the amount of the effect on that channel. We can also set the overall output of the effect with this pot. This equally impacts every channel with this effect applied. You may notice that we have several channel redundancies. We have a dry mic channel, and we have a wet mic channel. The dry channel is the raw, unaffected input source that is sent over here to our digital audio workstation. In here, the input source is mixed and treated with pitch correction and effects, and is then sent back to the board to a separate channel, which is the wet channel, or channels, if we dedicate a left and right for stereo mixing. We have 4 destinations we send audio: the house, the subwoofers, the live stream, and the in-ear monitors. Controlling individual channel volume in the house is done with these faders. Each channel fader is then routed to an output bus. As I select each channel, we can see that these buttons here begin to illuminate to display what bus that channel is being routed to. As we discussed previously, we have house main speakers and mid-fill speakers. So subgroup 1 and subgroup 2 are our left and right mid-fill speakers respectively. We bring these 2 faders up to an acceptable level and do the same for the main bus fader. Our live stream, in-ear mixes, and subwoofers are all routed through what's called an auxiliary bus. Each aux bus is assigned or connected to a specific destination. For instance, we can select aux 1 and see that it routes to the in-ear monitor mix of the vocalist on mix 1. By selecting this channel's mix button, we can mix the levels of the channels just like mixing effects. Again, these meters in the fat channel are linear to each individual channel and displays the decibel level of each channel. If I select mix on this channel, I'm now able to mix the levels for the live stream. This channel, mix the levels for the subwoofer left, and so on. Music being played from the Mac is controlled not by a fader, but from the 2-track in pot here. The pot adjusts the level being sent to the main bus. You will often need to mute channels, which is achieved by simply selecting the mute button in line with the channel. Additionally, any channel that is sent or received over the local network mentioned in the beginning must have this digital return button selected. Otherwise, you will not get sound. Serving as a soundboard tech can seem daunting, but with this training, more practice and experience, I believe that you will begin to understand on a more detailed level. And I also believe that understanding is half the battle, understanding of what's going on. With the patience to understand, the willingness to learn, and the diversity to grow, I believe that you will run this soundboard as excellent as ever. I hope that this training was informative and beneficial to you, and I'm excited to continue working in ministry alongside you. God bless you.